Rashmi ma'am is back here again, and I hope you all are keeping fine and you all went through the previous video quite well. So because this video is a continuation of the first one, so we are going to start from where we had left. In the last video we discussed about how the ions are formed, how atoms produce ions, and in this video we are going to continue with this topic. Okay, so I'm going to slightly touch every topic, although the atomic structure and the chemical bonding, all these things, there's a separate chapter. Okay, we'll be discussing it in detail, but slightly just touch all the topics so that you remember everything, you get reminded of all the things that you have learned earlier, right? So in the last class we have discussed how ions are formed. Now suppose let us take an example of potassium. Potassium, the electronic configuration of potassium, the atomic number is 19. Okay, so its electronic configuration is 2881. Yes. Let us take the example of chlorine, whose atomic number is 70. So the electronic configuration of chlorine will be 287. Now as you can see here, in the last class I had also reminded you about the octet rule and the duplet rule. That means what? Once again, every atom tries to attain the stable electronic configuration of the nearest inert gas. From atomic numbers 1 to up to from 1 to 20, you come across 3 noble gases or inert gases: helium, neon, and argon. Okay, helium, neon, and argon. So if we are discussing only from atomic numbers of in between 1 to 20, then these are the 3 inert gases that fall in this category, isn't it? So helium has an atomic number of 2, neon 10, argon is having the atomic number 18. Yes. So now let us take the example of let's come back to this example: potassium and chlorine. Potassium is a metal, chlorine is a non-metal, right? Potassium is a metal, chlorine, and you can see the outermost shell, that is called the valence shell, has 1 electron here. In case of potassium there is 1 electron. In case of chlorine there are 7 electrons. So let us, just for your information, let me write down helium, the electronic configuration is 2, neon 2, 8, argon 288. Yes. So as you can see here, you can understand from this electronic configuration that why these gases are called as inert or noble or non-reactive gases. Because you see, helium has already fulfilled the duplet rule, so it's stable, it doesn't react. Neon has also 8 electrons in the valence shell, it is satisfied completely. Argon has also 8 electrons in the valence shell. So every atom tries to attain the stable electronic configuration of the nearest noble gas. Now as you can see here, potassium, we have potassium here. The outermost shell has 1 electron, so if it loses 1 electron, definitely it will attain a stable electronic configuration. If this chlorine gains 1 electron, it will attain the stable electronic configuration. Potassium will attain the stable electronic configuration of argon, and chlorine too will attain the electronic configuration of argon, because the electronic configuration of argon is 288. That is why potassium loses 1 electron. Since 1 negative charge is getting reduced, the negativity is decreasing by 1. So it gains a positive charge, a unit positive charge. What about chlorine? Chlorine will gain 1 electron. So it is increasing by, it is increasing in negativity by 1. So that means chlorine will gain a unit negative charge. Okay. So what happens, as you have read earlier, that there are 2 types of charges, positive and negative. And if there is no charge, it is neutral. And unlike charges have an attraction towards each other. Unlike charges attract each other. So what happens, this K plus and Cl minus, there exists a force of attraction. There exists a force of attraction between them called the electrostatic electrostatic force of attraction. And it is this electrostatic force of attraction between the oppositely charged potassium and chlorine that results in the formation of a bond called the ionic bond or the electrovalent bond, right? That is named as what? Electrovalent bond, or the other name is ionic bond. Why the name ionic bond? Because it's the bond existing between two oppositely charged ions, and is also named as electrovalent bond. And the speciality of this bond is that here basically the actual transfer of the electron is taking place. That means basically potassium is losing its electron. It's donating its electron, and chlorine is accepting the electron, because potassium is having one extra electron and chlorine is deficit by one electron. So by doing that, both of them attain the stable electronic configuration of the nearest inert gas, that is argon, right? And they become stable. So they stay together. And this is nothing but a molecule. The product which is formed is a molecule of potassium chloride. So we have read that atoms combine chemically to form molecules. And what is the reason behind their chemical combination? The opposite charge between them results in electrostatic force of attraction, and this electrostatic force of attraction results in the formation of the ionic bond or the electrovalent bond that holds these two different atoms together, giving rise to a molecule. Now, this is a molecule made up of two different kinds of atoms, right? But we also have bonds existing between the same kind of atoms. Like, let us take the example of hydrogen. One molecule of hydrogen, one atom of hydrogen is H, but one molecule of hydrogen is H2, because one atom of hydrogen cannot exist independently. It cannot exist independently. So what it does? It enters into bond with another hydrogen. Likewise, chlorine. One atom of chlorine is unstable. So it enters into bonding with another chlorine. So what does this mean? So this is what, as you can see here, let me come to the previous one. You can see here the potassium is a metal, chlorine is a non-metal. So electrovalent bond usually takes place between a metal and a non-metal, okay? But now you can see here this bonding is taking place between two non-metals, right? Two non-metals. Like we have for different metals also, for different non-metals also, like we have NH3. So in this case also there is a covalent bonding. So you have already read about the electrovalent bond and the covalent bond. So what is the difference, the basic difference between these two bonds? Actually what happens here? Here basically the actual transfer of electron is taking place. But in the covalent bond, there is a mutual sharing of electrons. As you know, hydrogen has only one electron in its valence shell. So it will try to attain the stable electronic configuration of what? Helium. Yes, to become stable. Everybody wants to become stable in their life, right? So hydrogen will try to attain the stable configuration of helium. So what happened? What these two hydrogen atoms do? Both of them enter into chemical bonding. They share their electrons, so that each hydrogen, as you can see here, each hydrogen now gets two electrons. Each hydrogen now gets two electrons and becomes stable. Since they are unstable, they join together. What about chlorine? Chlorine has 7 electrons. 1, 2, 3, 4, 5, 6, 7. Likewise here also. Yes. So what they do? They share one electron each. They share 1 electron each. So now one single chlorine atom has obtained how many electrons in the valence shell now? Complete 1, 2, 3, 4, 5, 6, 7, 8 electrons. Now each is having 8 electrons in the valence shell. Okay. So this type of bonding where the mutual sharing of electron is taking place basically between two or more non-metals. It's called what? Covalent bonding. The product which is the compound which is formed as a result of this bonding are called as covalent compounds. The bond that exists between two oppositely charged ions because of the electrostatic force of attraction is called as the ionic bond. And the compound formed as a result of this bonding is called as electrovalent compounds. So I think the idea is very clear here. So this gives rise to what? So this is what basically a molecule. The molecule of chlorine, the molecule of hydrogen, okay, a molecule of ammonia, a molecule of potassium chloride. So molecules are formed by the combination of same atoms or two or more different atoms, just in order to fulfill the octet rule or the duplet rule. So this is the reason behind every chemical combination. Okay, so now let's come to the next topic. From here only I will be connecting with the valency so that you can become more clear with the concept. Now let us come to valency. Now what is this valency? You have read in your earlier classes. The modern definition of valency says that valency is the combining capacity of an element. Valency is what? Basically the combining capacity of an element, right? Let us take the example of sodium. 11. Atomic number is 11. 281 is the electronic configuration. Let us take the example of magnesium. 282. Let us take the example of nitrogen. 25. Let us take the example of carbon. 24. Okay. So now, what does valency mean? Valency is the combining capacity of an element, right? So now, as you can see here, how many electrons enter into chemical reaction for sodium so that it attains a stable configuration? 1 electron. That is why sodium is known as what? Monovalent. You must have come across monoatomic, diatomic, monovalent, divalent. Both are completely different. Don't get confused between these two things. They are not same. Monovalent means having valency 1. Divalent means having valency 2. Now, why magnesium? So, sodium is what? Monovalent. The word added here will be, the prefix will be monovalent. What about magnesium? Magnesium, 2 electrons are involved. 2 electrons are lost, right? So, it is what? It is divalent. It is divalent. What about nitrogen? It needs 3 more electrons. It will gain 3 more electrons. So, it is a trivalent element. Now, what about carbon? You must be thinking whether carbon will lose or gain electrons. So, basically it enters into covalent bonding only, okay? So, 4 electrons are shared. So, it is called as tetravalent. So, likewise, we can define valency as the combining capacity. That means what? The number of electrons gained or lost during a chemical reaction. Okay, that is called as what? The valency of a particular element. And we have monovalent, divalent, trivalent, tetravalent. Like that, we have the elements basing on the valence shell. That is the basing on the electrons present in the valence shell. So the valency word has come from the valence shell. You know, valence shell is the outermost shell of an element. That means it refers to the number of electrons which are gained. So in this case, in the case of sodium and magnesium, we can see they are sodium is monovalent because 1 electron is lost. Magnesium is divalent because 2 electrons are lost. Nitrogen is trivalent because 3 electrons will be gained. And carbon is tetravalent because it will share 4 electrons, enter into covalent bonding. Okay. So now let's come to the next topic. So with this, I hope the idea is clear. But then you must have read 2 more definitions of valency. Yes. What are the 2 more definitions of valency? Earlier it was given that valency also refers to the number of hydrogen atoms. Yes. Like suppose let us take the example of HCl. HCl, you know, it's the formula for hydrochloric acid or hydrogen chloride. Yes. So here you can see here a covalent bond exists between these two non-metals, that is hydrogen and chlorine. So with how many atoms of hydrogen is chlorine combining? With one atom. So the valency of chlorine is 1. Likewise also, previously the valency was defined. Yes or no? Now suppose let us take the example of water, H2O. Okay, H2O. So what is the valency of oxygen? Oxygen, it is combining with how many atoms of hydrogen? 2 atoms of hydrogen. So the valency of oxygen will be how much? 2. Let us take the example of ammonia. Nitrogen is combining with how many atoms of hydrogen? 3 atoms of hydrogen. So the valency of nitrogen will be 3. Let us take the example of methane. Carbon is combining with how many atoms of hydrogen? 4 atoms of hydrogen, right? So the valency of carbon will be 4. So likewise also valency can be defined. The other way of defining valency is double the number of oxygen atoms. It's what? Double the number of oxygen atoms. Valency can also be defined as double the number of oxygen atoms. As you can see here, suppose let us take an example of sodium oxide, Na2O. Okay, so in this case, yes, 2 atoms of nitrogen combining with 1 atom of oxygen. Okay, so now for each and sodium there is half of oxygen. There is half of oxygen. So double of half will be how much? Double of half will be 1. So valency of sodium is 1. Let's take the example of magnesium oxide. How many oxygen atoms magnesium is combining? With 1 atom of oxygen. So what is the double number? 2. So the valency of magnesium will be how much? 2. So likewise, we can take the example of carbon dioxide. Consider carbon dioxide. So here with how many atoms of oxygen carbon is combining? 2 atoms. So double it. It's 4. So the valency of carbon is 4. So that way also it was defined, but the modern definition is what I told you earlier. That is what? The number of electrons gained or lost during a chemical reaction refers to the valency of that particular element. And that is more appropriate, okay, for all of us. Now, let us come to the next topic on valency, that is called as a variable valency. Variable valency. Now, what is this variable valency? You must have read earlier that some elements show more than one valency. Till now, I have been saying you that atoms present in the electrons present in the valence shell are involved in a chemical reaction, right? But sometimes, what happens? Electrons are also lost from the penultimate shells. That means from the inner shells, not only from the outermost shell, but also from the inner shells. So from atomic elements falling in between the first 20 elements of the periodic table, we don't have this. So let us take the example of copper. Here, I would like to give you the example of copper. Okay. So the copper's atomic number is 29. So how will you write the electronic configuration? Now in this case, you cannot follow the rule that I told you in the last class. That is 2, 8, 8 and the remaining electrons. We cannot be followed here. So here we will be following the 2n square formula. The K shell, L, M shell, N shell. Okay. So here N refers to the shell number. That means K shell's number is 1, L is 2, 3 is M is 3, N is 4, like that. So you put the formula 2n square. Yes or no? So according to that, so what will be the maximum number of electrons here? 2 into 1 square is 2. Then here 2 multiplied 2. 2 square will be 8. 2 multiplied to 3 square will be 18. Likewise, 2 multiplied to 4 square will be 32. So here we will be following this rule, okay? This is the actual basic rule. So now 29, the atomic number of copper is how much? 29. So let us write in the electronic configuration of copper. What is the electronic configuration? The first shell will have 2, the second shell will have 8, the third shell will have 18. So now 8 plus 2, 10, 10 plus 18, 28. So the outermost shell will be having how many electrons here? 1 electron. So this one electron will be participating in the chemical reaction. So in that case, what happens when this one electron participates? It forms cuprous ion. It forms what? Cuprous ion. In that case, it forms what? Cuprous ion. But now sometimes what happens? Now that study, we'll be studying that in detail later on. Okay. So now what happens in that case? 2, 8, 17. Sometimes what happens? The electron present in the that means here this is K, L, M, N. In the M shell, jumps to the valence shell. Jumps to the valence shell by gaining energy, because the shells are the energy levels. Okay. So what happens? And in the chemical reaction, these 2 electrons are lost. So since 2 electrons are lost, it becomes what? Cu, having a charge of 2 plus. And this is called as cupric. This is called as what? Cupric. So sometimes, so for the variable valency for your class, you need to remember this much, that sometimes apart from the valence shell, electrons are also lost from the penultimate shells. Okay. And the detailed study is not needed for you now basically for this class. But then you have to understand the concept that electrons are also lost from the penultimate shells, and because of these, certain elements show what? Variable valency. So what will be the electronic configuration of cuprous ion? The electronic configuration of cuprous ion will be 2, 8 and 18. What will be the electronic configuration of cupric ion? 2, 8, 17. Right, 2, 8, 17. Okay. So students, let us end the topic here for today, and I hope you all will go through the video well and try to understand everything that I explained today. Keep studying and complete your assignments and keep practicing. Okay. So till then, take care.